All right, we're back. It's going to talk about spine flexion because that's all anyone wants to talk about again. I did a post last year critiquing a case study that was out there, just saying that they measured spine flexion wrong. And I got tagged into Instagram again with the Squat University, which essentially said if you really understand spine flexion and you know how to measure it, then you would be able to make better conclusions. You know, it was a little knock on me, but that's okay. So the basic argument behind it is that spine flexion is inherently bad, and you want to be able to avoid it to decrease your injury risk. Some people have said through the years, maybe people take it too far, and I've done this with the blog. It's a bit nihilistic and just sort of saying, well, we can't really avoid spine flexion if we're lifting from the floor, so maybe it's not worth worrying about. Where that argument would go too far is people would say that it can't be changed at all. I'm just saying that lots of flexion occurs, and even your best lifters, people who are trying to avoid spine flexion. And I put a number of posts on Instagram with little measurement tools that I have, which I'll show you in a second here, where I myself, I like to lift deadlifting, and I have around 70 to 75 to 80% of max flexion. I can change it and get to like 60% of max flexion, you know, so it is modifiable, but you're certainly not going down to like neutral, or, you know, which would be like maybe 20 to 45% of max flexion. And you're certainly not going to zero. But anyways, I put out a post last year where a paper came out and said, look how great this case study is. People can really alter their spine flexion and can totally reduce it. And I just said, you're doing it wrong. You calculated spine flexion wrong. So here's a post, April 1st, 2024. Let's quickly look at it. The way you measure spine flexion, what they did, which is fine, is they put goniometers on the spine. So one's at T12 and one is at S1. These little guys, I've just started playing around with. If you want to buy them, they're not even that expensive. These aren't the ones I use, but it's Meta Motion Monitor. They give you dynamic tracking, and they just go on. And so the T12 would go there, S1 would be there. See how it's like on an angle like that? So you calculate the difference between the two angles, and that is what gives you spine flexion. So if you notice here, this would be considered zero, right? That would be zero, and then you flex. So lumbar spine flexion is a combination of what the sacrum does and what happens at the lower thoracic spine. You subtract the two numbers, and that'll give you a number. So what they did in their initial paper, right, is they had standing neutral was at 35 degrees, and then they had the person flex all the way down, and they got 69 degrees. Now, where people would go, I'll show you where they went wrong in a second here. And then they said loaded max neutral had 29 degrees of flexion. We won't go into loaded max flexion. So max flexion total was 69 is what they said. And then if you were just doing a deadlift, and actually they did an isometric contraction from halfway up, they had 29 degrees of flexion. So what they erroneously concluded was that neutral lifting, although it was isometric, avoided 40 degrees of flexion, right? So if you rolled all the way forward, you went 69, and look, you could lift here and only do 29. So they're like, oh, we reduced flexion 40 degrees, and that's 58%. And so they made the conclusion that neutral lifting had people lifting at 29 divided by 69 degrees, so 42% of their max. And people would argue that's good. That's probably within the neutral zone. You know, it's a debate where neutral is, but it might be around 40. And I would say, I get what you did there. That seems simple, but you made a big mistake because they got zero wrong, right? They ignored, I'm going to go back here, the minus 35 degrees. So the total range of motion is the difference between minus 35, right, and 69 degrees. So they needed to add those two together. So it's the absolute value of minus 35, which is 35, plus 69, right? So the total range of motion was 104 degrees, which is quite a lot. I don't typically see that with measurement tools, right? So there's 104 degrees of total range of motion, and their actual value for the range of motion in the neutral posture, right, was minus 35, the absolute value, plus 29 degrees, right? Does that make sense? So they went from extended and then they lifted in the neutral position, right? And the spine moved about 64 degrees, right? So spinal motion was 64 degrees divided by 104 degrees, the total motion, right? So it really moved 61.5% of max flexion, which is exactly what we found with everybody else. And the reason we do percentage is because we want to compare across people, right? Someone else might only have max flexion of 70 degrees, right? When they go and touch their toes and things like that. So this is called normalizing, allows you to compare. Okay. So then they just said, all right, Greg, maybe we listened to you. And the problem is they tried to correct it, but they calculated it wrong again. We're just on Instagram. That's why this is out. Say, no. Greg's wrong. We didn't make any errors. Look at the third reference that they cited. So here's the third reference. It's really tiny there. Measuring one's ability to alter, change, and reduce lumbar flexion on call, and underload. I don't know what that means. Part 2, because they read it, said, "Oh shit, we did it wrong." So this time was better. They now calculated. I'll throw it. I'll go in a second. They calculated it properly. They said, that when you start upright, that should count as 0 essentially. And then what they did was kind of neat. Was day 1 with no warm up, and they said, oh well, what if we do a warm up and do some training first, and then we look at how people lift, right? So their max flexion on day 1, they said was around. Total range of motion was around 40, and then the next time when they warmed up, it was almost 60. And then they said, here, look, if you warm up when they go to do the isometric lift, I'll explain this in a second, it had, over 20 degrees of lifting, but we were really good at reducing the lifting again. So just their conclusions, the participant flexed 26 degrees on day 1, which was 61.9% of the total flexion. Right? And then on day 14, after the warm-up, they flexed 11 degrees, and they said that was 18.6%. So implementing the warm-up increased both extension and flexion range of motion, also seemed to enhance the lifter's ability to alter, change, and reduce lumbar flexion on call and under load. Right? But that's the thing. They got this wrong. Let me show you. Let's go through this. So calculating spine flexion correctly. So the starting position was minus 16 degrees. Good. All right. Then they flexed forward, right? Max flexion, they got to 26 degrees. I know this is completely different than the other numbers. Don't get caught up in those. I don't understand why it's so different. But max flexion was 26 degrees. So the total flexion, what's it going to be? The absolute value of minus 16 plus 26 equals 42 degrees. That's how much the lumbar spine moved from being upright to going down all the way. And then when they did an isometric hold, I don't know if you can see this, I'm in my hotel room, it was just lifting from here. When they did an isometric hold, trying to be neutral, right? There was 10 degrees. But remember, that's not 10 degrees of total flexion. That would be 10 degrees plus, the absolute value of minus 16, right? So they calculated the spine motion during the isometric lift. So that's 26 degrees. Therefore, the total range of motion during the isometric lift would be 26 degrees divided by 42 degrees, the total, like when you flop all the way down and touch your toes. So they said it was 61.9%. Yay, that's bang on. This is consistent with how everyone measures spine biomechanics. 61.9% of spine flexion during an isometric lift when someone was trying not to bend their spine. Here's where they did it not correctly. I don't get it. Like, who the hell? There's no peer reviewers. I said, who are the peer reviewers? There's no peer reviewers here. It's not a real journal. So here, They started at minus 28 degrees. Again, you're going to have variability across people. They then went and touched their toes. So they flexed all the way down and had 31 degrees. So max flexion, is it 31 degrees? Nope. Remember, it's 31 plus the absolute value of minus 28. So that's 59 degrees. So total spine flexion was 59 degrees. That's consistently what I find, you know, when I use this stuff, and in the past when I used it a lot more. Now the isometric hold, guess what the spine position was? 11 degrees of flexion, okay? And here's where they went wrong. They just took that absolute value of 11 degrees. That's what the sensor said, 11 degrees, the difference between the two. And so what they did again here wrong was they took 11 degrees. So the calculation of the spine movement during the isometric hold, they just said it was 11 degrees. What they did wrong here was they just then took 11 degrees divided by 59, the total range of motion, equaling 18.6%. And they said, aha, Greg, I told you we can really minimize spine flexion. I'm like, oh my God, you did it again. You didn't do it right. You didn't really have 11 degrees of motion. You had 11 plus the absolute value of minus 28. You forgot, you ignored someone going from the upright posture, right? Correcting that extension and then flexing forward. You ignored 28 degrees of motion. You completely forgot about it again in your math. I just can't believe this got through. So it's really minus 28, the absolute value, 28, plus 11 equals 39 degrees of total lumbar flexion when you do the isometric lift at 50%. So it's 39 divided by 59, 66.1%. So in summary, you didn't do anything. You showed what everyone else shows. On day one, 61.9% flexion when you tried to minimize flexion. Fantastic. And you're not even lifting from the floor, and you're not even moving. And day two, with all the warm up and priming, you got 66.1% of max flexion when you lifted. All right, I'm glad that you contributed to my conclusion from years ago. I appreciate the work done in the field that we can have some agreement here. All right, adios. Fucking hell.